Welcome to homework.
Okay, so the answer here is basically none of the above. So what I've gone and done is just redrawn numbers 1 through 4. 1, 2, 3, and 4, and I've redrawn them as chairs. Right? Because recall that in order for an E2 reaction to proceed, we must have that the leaving group is anti-periplanar to a hydrogen on a neighboring carbon. Right? So, for example, this chlorine could eliminate with a wedge to hydrogen here, or a wedge to hydrogen here. Right? So anytime that the chlorine is neighboring a wedge to hydrogen on either side, or a dash if the chlorine is on the wedge, and that means elimination is possible on that side. What we'll find when we draw the chair form of each of these molecules in which chlorine is axial is that no matter what, chlorine will always be neighboring two carbons which bear axial hydrogens, right? Which means that none of these are capable of only giving a single stereoisomer. Contrast that with, say, if we had a chair that looked like the following. Right? If we had a dash to chlorine there, and a wedge to a methyl here. Now suddenly, if we were to draw the chair for this, right, we'd have axial chlorine here, axial methyl there, axial hydrogen there, and suddenly there would only be one bond that we could do elimination and get a double bond on that side, right? But we don't have a single cyclohexane chair for which that is the case. In each case, if we draw the chair form, we draw the chlorine axial, which is also necessary for each reaction to proceed, we'll find that there's always a hydrogen on both sides. Right? Now, in each of these cases, I've used the same numbering scheme, carbon 1, 2, 3, 4, 5, and 6. Okay. So, chlorine, carbon 3, it's a wedge, it's axial, okay? Hydrogen on both sides. Okay. Number 3, okay, number 1, 2, 3, 4. Chlorine's on carbon 4. It's underneath. Okay, so we're doing axial. Underneath the ring, okay, there's a hydrogen axial on carbon 3 and a hydrogen axial on carbon 5. Right, you can do elimination on either side. Same thing for number 4. Okay, 1, 2, 3. Right, we've put chlorine on carbon 3, we've made it axial, which is a necessary precondition for E2. Okay, and we see that, there's a hydrogen on the neighboring carbon, which is axial on either side. Right, so none of these will only give a single E2 product. It's just not possible, right? Which means that all of these, if there's a none of the above answer, that's correct, or whoever wrote the problem made a mistake, and the only viable answer would be what I drew earlier, something like this. Sorry.